Hello guys, so welcome back to our online organic chemistry lecture series, and this time we'll look at how to give names for carboxylic acids, and in a while we'll look at how to give names for its derivatives. So carboxylic acids, how do they look like? Basically, carboxylic acids are organic molecules containing the acyl group, which we have learned in the previous discussions. An acyl group is composed of an R group and a carbonyl carb and a carbonyl carbon. Okay, so if the carbonyl carbon is attached to a hydroxyl functional group on OH, then this one is called a carboxylic acid. Now, the derivatives of carboxylic acids, we have different substituents that replace the hydroxyl functional groups, which we will learn in a while. Now, how do we give names for carboxylic acids? The systematic names for carboxylic acids are derived by counting the number of carbons in the longest continuous carbon chain that includes the carboxylic acid group. Now, we have to replace the E of the corresponding alkane by oic acid. So for example, if I have a 1-carbon carboxylic acid, that is called methanoic acid. If I have, for example, a 2-carbon carboxylic acid, example, we have something like this. This is 2-carbon, that is carbon 1, and that is carbon 2. This is known as ethanoic acid. So we follow the same way of naming, that is to replace the E with oic acid. So for example, if I have here this carboxylic acid, okay, and so for this carboxylic acid, this is carbon number 1. The carbonyl carbon is always carbon number 1, and then this is carbon number 2, this is carbon number 3, and carbon number 4. So we have a 4-carbon carboxylic acid. So this one is known as butanoic acid. Now, if the carboxylic acid is ionized, so meaning if I have this one as an O negative, then that becomes a carboxylate, and we should just replace the oic acid with O8. Now, how do we give names for the carboxylic acid derivatives? But before that, we should know how to recognize carboxylic acid derivatives. Okay, let's start off with what we call as anhydrides. So anhydrides are organic molecules containing the acyl group, such as this one. Okay, and you have here an oxygen, and this oxygen is bonded to another acyl group. So we have here what we call as your anhydrides. So we have here the general formula for anhydrides. In naming anhydrides, we have to remove the word acid, and we just have to add the word anhydride. How do we recognize acid chlorides? So acid chlorides basically have here the acyl group, this R, C double bond O. Okay, and we have here a halogen. So if the halogen is a chlorine atom, then this is called an acid chloride, and the name ends in oil chloride. So if this one is a bromine atom, then it's called a acid bromide, and the naming ends in oil bromide. So how about an ester? Okay, an ester basically you have again the acyl group. That's an acyl group. So you have here the carbonyl carbon that is attached to an oxygen, and this oxygen is attached to another alkyl group. So this is the general formula for an ester. For an amide, we have the acyl group, and in the acyl group, the carbonyl carbon is attached to a nitrogen, and this nitrogen can have a hydrogen, or this nitrogen can also have alkyl groups in lieu of the hydrogen. For nitriles, this has a very different structure because this doesn't have the acyl group. Rather, nitriles have a carbon, and that is bonded to your nitrogen. So C triple bond N is a nitrile. So how do we give names for esters? The ending will be O8. For an amide, the ending is an amide. And for nitriles, the name ends in nitrile. So if we compare these different derivatives of carboxylic acids, we notice that the anhydrides, the acid chlorides or acid bromides, the esters, and the amides, so all of them have an electronegative atom bonded to the carbonyl carbon. Now let's take a look at this example. So notice that for this molecule, we have this carbonyl carbon, and this carbon here is bonded to your chlorine atom. So this is actually an acid chloride. So the name for this one is pentanoyl chloride. Again, acid chlorides or acid bromides, you drop the IC acid and replace that one with ill chloride or ill bromide, depending on the halogen that you have here. Okay, so how do we actually number the chain? Now, for carboxylic acid derivatives, the numbering always starts at the carbonyl carbon. So, for example, this one is carbon number 1, then this one is carbon 2, this one is carbon 3, this one is carbon 4, and this one is carbon number 5. So if this is a carboxylic acid, then this is named as pentanoic acid. But since we have an acid chloride, then the final name is pentanoyl chloride. Okay, so let's move on to this example. So you notice that we have this structure, and this resembles the structure for anhydrides. So again, how do we give names for anhydrides? So we just have to drop the word acid and add the word anhydride. So we have to count the number of carbon atoms, obviously. So we have 1, 2, 3, this is 3, this is 4, and this is 5. So if this is a carboxylic acid, that is just pentanoic acid. But since we have an anhydride, we drop the acid and add the word anhydride. So this becomes pentanoic anhydride. Okay, so let's look at this example now. So we have here the carbonyl carbon, and this carbonyl carbon is bonded to an oxygen, and that oxygen is bonded to a CH3. So this group is actually an ester. And in naming ester, we actually drop the word ic acid and add the word ate. Okay, so how do we give name for this one? So we first give the name of the alkyl group, okay, that is bonded to the oxygen atom here, and this is methyl. So we have methyl, and then we have to continue naming this one by adding the word pentanoate. Why pentanoate? Because if you count the number of atoms, this side will have 5 carbon atoms. So this is pentanoate. Okay, so let's move on to this example. Again, we have to recognize that this molecule is an amide because the carbonyl carbon is bonded to a nitrogen. So how do we give names for amides? For amides, we drop the oic acid and add the word amide. So for example, so if this is the carbonyl carbon, again, we start numbering here. That's carbon 1. Then we continue numbering. So that's number 2. This is carbon number 3. This is carbon number 4. And carbon number 5. Okay, so if we assume that this one here is a carboxylic acid, then this is named as pentanoic acid. But because we have an amide, then this is named as pentanamide. Remember, we have to drop the word oic acid and replace that one with amide. So lastly, we'll try to look at this example. So this is a N. So if this is a CN, the first thing that should come into your mind is that you have a carbon that is triply bonded to a nitrogen, and this is actually a nitrile. So how do we give names for nitriles? All right, so for this example, the carbon bonded to the nitrogen becomes carbon number 1, and then this becomes carbon number 2, carbon number 3, carbon number 4, carbon number 5. So the name will be pentane nitrile. So these are just some examples of acid chlorides. In general, acyl halides are named by placing the name of the appropriate halide after the name of the acyl group. All right, let's take a look at more examples of acid chlorides. Focus your attention for this first molecule here. So we have to decide which one is the parent, and the parent for this one is chosen to be this. Okay, so this one is basically named as benzoyl chloride. And if you notice, we have another substituent here, which is a methoxy group, and this is at carbon 2 with respect to this one. Now, the acid chloride group is bonded to the benzene ring, and that gives this part of the molecule a new base name, and the new base name is called benzoyl chloride. Now, notice that at carbon 2, this is carbon 1, we have a methoxy group, and since we have a 1,2 disubstitution of the benzene ring, then we use the word ortho or the prefix O. Now, the final name for this molecule is orthomethoxybenzoyl chloride. Okay, let's try to focus our attention now for the second example. So we have here a straight chain molecule, and we notice that we have here your acid chloride group, and we have here your double bond. So between the acid chloride and the double bond, the priority goes to this one, the acid chloride group. So we start numbering at the carbonyl carbon to be carbon number 1, and then the numbering goes from this carbon to the left side. So this is now at carbon 2, this is at carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, and carbon 8. Okay, so the name for this molecule is now 2-octanoyl chloride. Okay, so we have to indicate the position of the double bond, and that's at carbon number 2. So you notice that we have here the letter E, and E belongs to another system of stating the configuration of the double bond. So we have actually the E-Z system. So E stands for entgegen. This just means that the priority groups or the substantial groups are on opposite side of the double bond. So for example, we know that this one here is bonded to a hydrogen, and this carbon here is bonded to a hydrogen. Now this group, okay, is priority over hydrogen. And if we look at this side here, this alkyl chain is priority over her hydrogen. So if we put a line here that divides this double bond, we'd notice that the priority groups are actually on opposite sides. So that is why we use E. Now, when do we use Z or Z? So this is used when the priority groups are actually on the same side of the double bond, similar to your cis isomerism. Okay, so let's look at this last example for acid chlorides, and we notice in this molecule you have a methoxy group, and you have this substituent here that are in 1,4 position. So in this case, we have to decide which group will be prioritized. So we have here this group, this 2-carbon group here, that's 1 and 2, okay? And we have this as a substituent. So the naming of this molecule will simply be para-methoxyphenylacetyl chloride. Now the parent becomes this part of the molecule, and this is called your acetyl chloride. And on this part, okay, we have your methoxyphenyl. This is methoxy, this one is methoxy, and this one is phenyl. So it's methoxyphenyl. And if you notice that this group is actually in a 1,4 position. So that's why we use the prefix para. Okay, so let's move on to acid anhydrides. So how do we give names again for acid anhydrides? So these are some examples of acid anhydrides. What things do we need to remember in naming acid anhydrides? First is that when the acyl groups are the same, we simply specify the acid and replace the acid word by the anhydride. So for example, in this case, we have actually the same acyl group. So what do I mean? This group is actually the same as this group. And how do we name this one? So we state the name of the acid followed by the word anhydride. So the name becomes butanoic anhydride. Or you can also name this one as butyric anhydride. Okay, so how about if we have an anhydride in which the acyl groups are not the same, such as in this example? So in this case, we just have to cite or state the name of the acyl group in alphabetical order. So for example, this part of the molecule is actually your acetic, and this one is benzoic. So the final name becomes acetic benzoic anhydride. All right, so acid anhydrides are normally prepared by reaction of 2 moles of carboxylic acids. Now, let's take a look at this specific example here. So you have here succinic acid, which is a dicarboxylic acid, and this can actually cyclize to form what we call as succinic anhydride. This is an example of a cyclic anhydride. So for this slide, we've seen 3 types of acid anhydrides. The first type is wherein you have 2 similar acyl groups bonded to an oxygen. In the second type, you have 2 different acyl groups bonded to an oxygen. And the third type includes a cyclic anhydride. Okay, so let's look at some more examples for esters. Again, how do we give name for esters? Okay, so we have to remember that for esters, the alkyl group and the acyl group of an ester are specified independently. So meaning there are 2 parts of an ester. We have the alkyl group and the acyl group. Esters are named as alkyl alkanoates. In this case, the alkyl group is named first, followed by the acyl portion. And the acyl portion is actually named by substituting the suffix -oate. All right, so let's take a look at the first example in this set of molecules. All right, so this is an ester. You should recognize that this is an ester because you have the carbonyl group, and this one is bonded to an oxygen, and this oxygen is bonded to a carbon. So this is an ester group. Again, we have 2 parts of an ester, the alkyl group and the acyl group. So this part of the molecule is the alkyl group, and this part of the molecule is actually the acyl group. Now, in naming esters, we have to cite or state the name of the alkyl group first, followed by the acyl group. And the name of the acyl group should end in -oate. Okay, so if we look at the alkyl group, this one has 3 carbon atoms. So this is your propyl. And if we look at the acyl group, this one is called your benzanoate. So the name for this one is propyl benzanoate. Right, so let's try to move on to the next example. Again, this is an ester. So the first thing we have to do here is actually to recognize which one is the alkyl group and which one is the acyl group. It is easy to recognize which one is the acyl group because that is the part of the molecule that contains the carbon double bond oxygen. So this means that this is our acyl group. Now, the other part is obviously the alkyl group. In naming esters, we have to state the alkyl group first, followed by the acyl group. This group is known as cyclopentyl. Now, this acyl group here is named as 2-butanoate. Notice that we also use Z here in naming the molecules. So again, Z is similar to your cis isomerism for alkenes. This just simply means that the priority groups or the substantial groups are on the same side of the double bond. Again, we can visualize this one by, for example, adding a line here, and we know that this carbon is bonded to a hydrogen. Okay, that's a hydrogen. And this carbon here is also bonded to a hydrogen. Between this hydrogen and this group, obviously this methyl group here becomes the priority. And between this hydrogen here and this group here, obviously this, okay, is the priority. Now, if you notice that the two groups are on the same side of the double bond, that's why we use the letter Z. Okay, so let's move on to the next example. So again, we have here this alkyl group, and we have here the acyl group. Now, the alkyl group is known as isobutyl, and the acyl group contains a cyclohexane ring. So this is named as isobutyl carboxylate. Okay, let's look at this last example here. So again, the first thing we have to do is to identify which one is the alkyl group and which one is the acyl group. Okay, so the acyl group is the group that contains a carbonyl carbon. So this one becomes the acyl group, and this one becomes our alkyl group. So the name will become ethyl, and this one, it's called phenyl acetate. So the name of the ester is called ethyl phenyl acetate. Okay, so these are some examples of your amides. Now, how do we give names for amides again? So the name of amides are derived from carboxylic acids by replacing the oic acid by amide. Let's look at this first example. So we have here the amide portion, and this group is bonded to a benzene ring, and because of this, the benzene ring will have a new base name, and the base name will be benzanamide. And notice as well that in this molecule we have a CH3 group or a methyl group that is bonded to this carbon, and this is in the third position with respect to this carbon. So again, if we have a 1,3 disubstitution, we have a meta. So the final name for this molecule is meta-methyl benzanamide. So let's take a look at this example. So you have here the carbonyl carbon, and you have here the nitrogen, and this forms the amide group. Now, in naming molecules like this, we need to find the longest continuous carbon chain, and that will become the parent amide. So numbering starts at the carbonyl carbon, so meaning I will start numbering from this part of the molecule, and I just have to find out where is the longest continuous carbon chain, and this is actually it. So we have here carbon number 2, this is carbon number 3, we have carbon number 4, and carbon number 5. Now the parent is actually pentanamide. Okay, so at carbon number 3 and at carbon number 2, we have substituents. At carbon 3, we have a methyl group, and at carbon number 2, we have an ethyl group. So the final name for this molecule is 2-ethyl 3-methyl pentanamide. So in these two examples here, you would notice that the hydrogens are replaced by an alkyl group. So for example, for this molecule, you have two methyl groups that replace the hydrogens. So this amide has the form an RC double bond O nitrogen, and you have here alkyl groups that replaces your hydrogen. So we have here a lone pair for the nitrogen. Okay, so all right, so for this molecule, we can actually classify this as the R group, and then you have here the carbonyl carbon, and then the nitrogen. And in this case, you still have one hydrogen that is present, and we have here another an alkyl group that replaces one of the hydrogens. Okay, so for these types of amides, we can use the N-alkyl or N-dialkyl substituted derivatives of the parent amide. So what do I mean? So let's try to consider this first molecule here. So the name for this one is NN-dimethyl cyclopentane carboxamide. So let's try to understand why this molecule was named as such. Again, if we have, for example, your hydrogens, okay, replaced by by two alkyl groups, then we have to use the capital letter N to denote that one of the hydrogens have been replaced by by an alkyl group. In this case, we use N and dimethyl to signify that there are two methyl groups that replace the hydrogens in the nitrogen. And then the parent is known as pentane carboxamide. So the final name for this one is NN dimethyl pentane carboxamide. So we will try to use the same way of naming this molecule. So in this case, since only one hydrogen has been replaced by a group, then we just use one capital letter N. So this becomes N-benzyl formamide. Where is this N-benzyl coming from? This is actually your benzyl group. And this becomes the parent. So this is N-benzyl formamide.